Hi everyone, welcome to my YouTube channel. Today my topic for this particular video is the generator function. So generator function is the if we compare the generator function with the normal function. So generator function also similar to normal functions. We can define similar ways like we can use def keywords, then function name, all things is similar. The one thing is change in case of generator function. We need to use the yield statement instead of returns. Like if we remember, like in normal function, we use the return statement to returns any value, any results in the end of any functions. But here, in case of generator, we use the yield keyword to return the value. And it basically used to generate values on runtime. So if we compare the generator function with simple function, so if a function is contain the yield statement like the yield keyword, then it become a generator function and it return the generator object. A generator function is also called a lazy iterators. And lazy iterator means like if we compare the like simple iterators, for example, the list and tuple, it load all the items. Once we execute loop over list over tuples, it load all the item into the memory while executing. But in case of generator iterator, it does not load all item into the memory. It does not load all item. It's load item one by one once we call the next function. So that's the luxury of generator functions. That's why we call this a lazy iterator. And that's why it's maintaining the memory optimization. That's why it's memory efficient. So that's the reason we use generator into the industry. So let me move further. So here are the first things is like we need the yield keywords in the generator function. So here are the details regarding the yield. So yield basically a simple statement and it's work very similar to the returns. We know the returns, we see returns in different functions. Similar way like the yield is also work. And when we call a generator functions or expression, it returns a generator iterable object. And further, we can assign this iterable to any variables. Similar to other objects, we can assign generator iterables also to any variables. And once we call the next method, then the code statement is execute. Once we call next method, then the statement under this function is execute up to the yield keywords. And then the yield is return the response, return the result as per the code, as per the statement. Yield here returning the response. And while returning the response, yield also like the maintaining the flow of execution. And also like in once yield is hit, then the execution is suspended. Once yield is hit into the functions and yield save the response, save the state of function, and then they return the response. Like yield basically maintaining all the function flow. It suspend the flow first, it pause the flow, and then save those values, save the function state, and then return the state. So that's the main functionality of yield. So here also same thing like the yield is maintain the flow of execution. And once yield statement is hit while executing, it suspend the execution and return the value and also save function state. So you can see here, same thing mentioned here. So that's the main functionality behind the yields, behind the generator, how the things is work. So that's why yield is so important. And when we again, for example, again we call the next function for this generator iterable, it return the next item from the previous save state. Yield is maintaining the state from the previous execution. Then again we call the next, then it return the value from the previous save state. And you can see here are the syntax. This is the syntax very similar to our normal function. You can see here def keyword, then function name, argument, then statement. But here one thing is changed. Instead of returned, we have the yield statement here. So that's the main change here in case of if we compare the generator function with normal function. Here are the nice diagram to compare a normal function with generator. So in case of normal function, you can see here, like the normal function is work normally, like it start the execution, then finish, and then it return the value in the end. So this way, like the normal function is work. But in case of generator function, right, once we call a generator functions, it return a generator object. First thing is generator object. And when we call the next method, you can see here next method. Once we call this method, the execution is start. Once in the code, this yield keyword is hit, then it returns the value, and execution is pause as mentioned here, and also save the function state, like the current values also save. And then again, like we call next functions, then it again start the execution, and it start from the previous save state. You can see here previous save state is now is return the value from the previous save state, like the next value from the previous value. And then pause again, like the once yield keyword is returns. So once yield keyword is found, then it return the value from the previous save state, and then again pause execution, again pause, and also like the now new state, new function state is also saved. So this way, like the generator function is work into the memory in behind the scene, how this work. So main functionality is controlled by the yield keyword. This is the very important. So next is move to the coding part. So let me show you first simple function. So here I'm creating a simple function with the def keyword, then the function name. And you can see here I'm not passing any argument. And in the case of statements under this function, these are the 6 statements. And first is the yield keyword to return a value. And this yield is returning the 1 in first execution. In yield is maintaining the state is 1. And once we call the next time, next time, then it run from here, like it start from here, like it return the true. Then third time is return the 3, 4, then 5, then 6. This way, like the yield is work. And once I call this, let me call this on runtime. So here I'm first calling this above functions, and here this is the like the generator object. Here I'm calling this generator functions to create a generator object. This is the generator object. And so you can see here, once I call this function, this is the like the function name, and this is the generator object. So once I call this generator object is created into the memory. You can see here, this is the memory, and this one is the generator object. Let me take the example. This one is the generator object, but this generator object is blank because as a lazy iterator, it's blank. And once we call the next function, you can see here next method, print next, you can see here, this is the next. And under the next, we pass this generator object, and then it load one item. You can see here, it load one. Let me draw one here. So you can see here, it load one into the memory. So this way, like the generator object is work and next is work, and the further the execution is suspended. As we know, like here, like the execution is run till here, this point, and then suspended, and this state is saved into the memory. Like the state, current state is 1 into the memory. And once we execute next again, once we call next again with this same object, you can see here, now it's returning the 2. Now it load 2 into the memory. So yield state is moved to 2. Like on the yield, it returning the 2 values, and then again post the function, and now current state is 2. And same 2 is loaded into the memory. So this way, like the generator function is work. Let me draw again. So in case of 2, suppose this is the memory and this is the generator object, then it return the 2. And then it load the 2 into the memory. In this example, basically it load 2 into the memory. There is no more 1 into the memory. Now it's load 2 into the memory, and state of the function is saved as 2 here in this part. And if we, after that, if we again call the next function, then it move to the 3, then 4, then 5, then 6 accordingly. And accordingly, yield is maintaining the state. So this way, like the behind the scene, how yield is work, how function workflow is work. I'm using a simple function. You can see here, simple function I'm defining with the def keywords, then function name, then passing a argument. And here I'm using a for loop to create items by using the Range function basically generate item up to these argument values. And then with the help of yield, I am returning the item one by one and also maintaining the state of the functions with the help of yield function here. Let me call this. Here I'm passing the 10. And in case of 10, then the range function start from the 0. You can see here it's returning the 0 first. And if next time I run, then it return the 1. You can see here. If I execute next time, it return the 1. So you can see here this way it's work. Further, I move to the benefit of generator function, why we require the generators. As we know, we already have list, we already have tuples like number of iterable objects. Then why we require generator iterables? What's the use case of this? What are the advantages of this? Why we require this into the industry? As we have number of iterable only, we can use the list, we can use the tuples. So these are the few advantages. First one is the memory efficient. So we know generator is a lazy iterators, like it work while we call it. It's load data while we call next methods. So you can see here same thing method. It loads only one item into the memory once we call next method. So we can handle big size of data. For example, we have the limited memory in our systems and we need to work on a big size of files, like our files containing million of records, but we have the like the limited GB RAMs in our system, limited GB memory in our system. Then we can use generator for iterators to load items one by one. So this is the one advantage, and we can use this into the industries where we have the like the memory constraint. Then we prefer the generator iterator as compared to the list or tuples. And next one is the generating infinite sequences. For example, if we work on the streaming data, so in case of streaming, basically in case of streaming, we stream data from one server to another server, or you can say we transfer data from one location to another location by using the streaming. And in the streaming, we need to take care the quality of the data to make sure like the no loss of the data. So we need to maintain the like the offsets, or you can say we need to maintain the record of the packets data transfer through this stream. And so in the streams, there is the possibility of the infinite number of packets, infinite number of offset. So we can maintain those sequence, or we can maintain those track by using the generator function, because generators retain the it from the previous execution, because it save the state of the functions function and then return the new items after the previous state. So this way we can maintain the records, or in case of infinite sequence also. The very important advantage of generator functions, we can handle the like the infinite, or you can say the big number of streaming data into the real-time applications. And next one is the pipelines. We can generally use the generator for the pipelines, because we know the generator work on the lazy operation, and so that we can prepare a pipeline to handle the big size of files with the limited RAMs, limited memory, and so can load big size of files into the memory easily with generator pipelines. And here are the one example. We assume, suppose we need to generate a function to produce even number, and then we need to increment those number by 2, and then we need to further perform some operation, for example sum or maximum, these kind of operations. Let me show you the code example. So here first I am creating a function like simple def keyword and the function name, and here I'm passing the argument here, and then I'm using the for loop. This is similar to the above, this sequence function, very similar to this. Here I'm again generating the value with the help of for loop. And then I have the condition. You can see here, if condition. Here I'm checking the value is even or not. In case of even value, it returning the value, and it return value with the help of yield keyword. You can see here. So this is the first generator function. You can see here, and this generator function basically checking the value and then returning the even value only. And then I create another generator function. You can see here, this is the next generator function. In this also I am use the same syntax and again for loop. And here I'm doing one thing. I'm increasing the value by 2. I'm incrementing value by 2. You can see here. First is the def keyword. Again, here simple function name, argument, then for loop to get all items from the argument, and then the yield statement to return the value with incremented. You can see here value with increment by 2. And if I call this generator, you can see here, first I am calling this generator function, this one, and I'm passing the 11 as a argument. So it basically return the value from 0 to 10, because a range function return value from 0 to n minus 1. So here n is 11, so it return 0 to 10. And in case of even number, it return the 0, 0, because even number, then it return the 2, it return the 4, 6, 8, 10, up to the 10. And in the next, you can see here, we are using here pipeline. So this is the function 1. In the function 2, we are incrementing those value by 2. And in case of 0, we increment 0 to 2. In case of 2, if we add 2 into the 2, then it would be 4. In case of 4, it would be 6. In case of 6, is 8. In case of 8, it's 10. In case of 10, it's 12. You can see here, finally, we are checking the maximum value, and it returned the 12. So this is work in the similar way, like it returning the max value is 12 in this case, so it returning the 12. So this is the like that why example regarding the how we can use generator, like the multiple generator functions in the pipeline. And next one is the generator expression. And generator expression, basically the similar terms we see in the list expression, as I discussed the list expression in details during our list videos, list data structure video. So in list comprehension, we create a list with one line of codes, like we define the for loops and all if conditions, all condition in one line. And with the help of one line, we can generate a list, or we can generate an iterable object. Similar to that, we can again generate the iterator, like the generator iterator here, with single line of codes. And this expression called the generator expression. One thing is changed if we compare with the list expression to the generator expression. In the list expression, we use the square brackets, but here we are using the round bracket. This is the only one change. Rest of the things is same. Coding is same, syntax is same. Just we need to change this bracket from square bracket to round bracket in case of generator expression. And if we compare the generator object with list comprehension, suppose we have the memory constraints, we have the low memories, so we prefer the generators expression instead of list comprehension. And suppose if we have the requirement of low latency systems like the fast system, then we prefer the list comprehension instead of generator expression. So let me move to the coding part here. So this is the very basic example to generate a generator object with the help of single line of code. You can see here I'm generating a generator object again with for loop. You can see this is the for loop, and in the for loop, I'm defining a range function. With the help of range function, I'm creating the value, and further I'm taking the cube of those value. So if you compare this is similar to the above codes. You can compare this with this code. This is also the similar code, and here we are using the three line of code. But here we are doing all stuffs like the similar stuff in single line of code. So that's the compact way to write a generator function. So this is the generator expression basically. And if we call this generator expression first time, so let me run. First I'm running. So here I'm creating a generator object, and if I call this generator object with next method, it returning the 8. So as you see in the range function, it start from the 2. And if we take the cube of 2, then it's 8. So it returning the 8. And if we call this next time again, if we call next method again, it returning the 27. Because after the 2, it return the 3 here, and cube of 3 is 27. So that's why it's returning the 27. So this is also work in the similar way as we see here in the generator functions, as I show you in this basic functions and this sequence. So similar way, generator expression also work here. And let me move to the comparison of these generator functions with list comprehension from the memory optimization point of view. So here first I'm using a library, system library, and this is dot get size of function to return the size of the object. And here I'm using the generator expression to generate a objects like the a generator object. And here I'm printing the size of this generator object from the memory optimization point of view. And you can see here it's just 128 byte size of this object. And if we create same object, similar object with list comprehension, here the logic is same. If you can see here, the for loop is same, range value is same. If we compare with the generator expression, only here we using the scale bracket. So we are using here list comprehension, and then we are creating the list iterable object here. And again, we are checking the size of this object. And if we run this, you can see here, now the size is changed, the huge change. You can see here 4,06,504. This is the impact of memory point of view, the generator and the list comprehension. So list is taking lot of memory because list loading all the data, all the items in one go. And generator function is lazy iterator. It load item one by one only when we call the next method. So that's why in case of low memory, in case of memory limitation, then we prefer the generator. And let me compare the speed or you can say the latency of generator expression with the list comprehension. So here I'm using the C profile library. C profile basically capture the runtime speeds, or you can say runtime time taken by a particular statement, particular code, and then print all the time taken by the all calls, total times, and per call times like the average, and all things like all modules called by those functions or those code statement. And if I first run the generator expression here, you can see here, first I'm running the generator expression. And in case of generating expression, it's taking the 0.254 seconds. You can see here, in case of generator expression, it's taking the 0.254 second. And if I run the same code, you can see here, code is same. I just change this code from generator expression to list. You can see here, only I change the bracket from the round bracket to square bracket. So basically I'm changing this generator expression to list. And if I run this, you can see here, it takes the 0.195 second. So if we compare this with generator, so you can see here, this is like the list comprehension is fast if we compare this with the generator expression. So that's why we mentioned above also, like in case of low latency requirement, then we prefer the list comprehension. In case of memory constraint, then we prefer the generator expression. So that's all about the generator function. So here in this video, I cover the generator function, generator objects, how we can call the next methods, how the yield statement is maintaining the state of the functions, how yield is returning the next value on every time, how the execution flow is posed by the yield statements. And also I show you how we can use the generator functions in case of big data size or big size files. I also compare the performance of generator expression with list comprehension from the memory point of view, as well as from the speed or latency point of view. So that's all about the generator functions. If you want to use this code, and if you want to rerun this code or practice this code at your end, you can find the link of this colab in the description of this video. And thank you for watching this video. Please like and subscribe my channel. And thank you.